from radical mechanism. Addition of hydrogen halides in a
So your voice is breaking.
Maria, Ayman. Madhya, am I audible clearly? Darshan, please do
Yes,
respond.
sir. Now
Any
I
one
can
of you.
hear.
Okay, thank you. So we had completed only the representation of haloalkanes. Now we are going to study about the physical properties. Darshan, now I think my network is good. Let me know if my voice is gonna lag or anything. Wait a minute, let me put this in charge. Sorry. I need to- Okay. So going to start physical properties of haloalkanes and haloarenes. Physical properties. In physical properties, we are going to talk about melting point and boiling point first. Melting point, melting and boiling points. So how we are gonna decide whether which one will have higher boiling point or melting point and which one will have lower melting and boiling point. So it's very easy to decide. First, I'm going to talk about boiling point. Basically, if the force of attraction between molecules or the particles of the molecules are very high, it is very tough to break the bond or to you can see the boiling points of that molecule will be higher because the force of attraction between the particles is high. To break the force of attraction, we will require more energy. That's why boiling points are. On what factor this boiling points depends? So the first point is basically boiling points directly proportional to molecular weight, molecular molecular weight. As we know that from class 11, if molecular weight increases, that means van der Waals force of attraction, VFOA, that is stand for van der Waals force of attraction increases. They are directly proportional to each other. If molecular weight increases, that means van der Waals force of attraction also increases. Okay, so force of attraction increases, that means boiling point also increases. Now the second factor is basically surface area. Surface area and inversely proportional to branches. If molecular weight are same, that means they are isomers of each other. Okay, so one will have more branch and one will have less branch. So more branch, that means surface area less. Surface area less, that means boiling point less. Is that clear, Madhiha? So if we are
Yes, sir.
going to talk about this, wait a minute, you are going to compare boiling point of this CH3, CH2, CH2, CH2Br. Then I am going to write this CH3, CH2, CH, Br, and then CH3. Now CH3, C, CH3, and again CH3, Br. Can anyone tell me which one will have highest boiling point and which one will have lowest boiling point? It's very easy. After understanding this concept, you can easily go for this question. Please answer me. Darshan, Ayman, Nadiha. So first of all, you are going to decide which one will have higher molecular weight. So if you are going to see, you will see that all have the same molecular formula. If molecular formula are same, that means they have same molecular weight. That means they are isomers of each other. Okay. So same molecular weight. That means we are not gonna decide on this factor molecular weight. So how we are gonna decide on base of surface area or branch? You can see the surface area of this is high or more than this. So this will have more boiling point, most boiling point, and then this, and the lowest boiling point is will have this compound. I think it's clear. Madiha, is there any doubt? Darshan, Ayman, thank you. Now I am going to give you. Before that, I'm going to explain for melting point. So see, melting point basically depends upon packing. If the packing of particles or molecules are very tight, it is very hard to melt that particles or molecules. So basically melting point depends on packing. So I'm going to give you a question. This is fluorine, this is fluorine, this is orthochlorine, this is metachlorine, meta, and this is para. This is para. So see, is everyone done up to this part? Boiling point? Please do respond in chat box at least, please. Okay, thank you everyone. Yes. Now I am going to compare these compounds for melting point as well as boiling point. So I'm going to take it A, B, and C. You know what? The packing of these molecules, paramolecules, will be higher because it is in symmetrical way. So for melting point, basically C will have the highest melting point, then B, and then A. What about boiling point? You can see the all have same molecular formula, but when we talk about boiling point will be highest on ortho because it is very stable compound. So A and then C and then B. So please write it. Let me know when you are done with this. Can you solve this question? Anyone got any answer? Please do let me know. I'm waiting for everyone's reply. Am I audible to all of you clearly? Okay, no problem. I'm requesting everyone to do reply whether you are able to solve it or not, or whether you are still solving it. So see, it's very easy. If you are going with the concept, bromoethane. Do you know what is bromoethane? So you know. First of all, let me correct this. Since we are talking about methane only, so this will be like this. Okay. So now I'm going to write the structure of this bromomethane. That means CH3Br. Bromoform, chloroform, iodoform. Always remember this. There is three Br will be there. There will be three Br. Okay. I'll check it, Madhya. If it is chloroform, that means CHCl3. If it is iodoform, that means CHI3. So bromoform, that means CHBr3. Chloromethane, that means CH3Cl. Dibromomethane, that means CH2Br2. Can anyone tell me which one will have highest molecular weight? Since 3Br is here, 2Br is here, 1Br is here, 1 chlorine is here. So this will have the highest molecular weight. So that's why it will have highest boiling point B. And then D, then A, and then C. Was this your answer? B, then D, then A, C. Very good. Very good, Madhiha. And I think it's clear to you. If it is still not clear to you, or you need another explanation of this question, please let me know. Okay, please write it and let me know. What about you, Darshan? You're not responding at all. I'm going to. Okay, Darshan, please write it and let me know when you are done with this. Aman, are you done with this? I'm going to give you the second part of the question. That is, and I think you can do it. 1-chloropropane, isopropyl chloride. This is common name. Isopropyl chloride, and then 1-chlorobutane. 1-chlorobutane. So this is a this is B, and this is C. Please arrange this. Very good, Nadia. Any answer from Ayman and Darshan? If you are unable to solve this, please let me know. Hmm. Uh, do you know what is the structure of this? This will be CH3, CH2, CH2, and this. Do you know what is the structure of isopropyl? Basically, this is 2-chloropropane. And what is the structure of butane, chlorobutane? So you can see this is the structure of chlorobutane. Now, your most boiling point will have the compound this butane because it has higher molecular mass. So C is the greatest one. Can you tell me? So this A and B are isomers. Since they are isomers, they will have the same molecular formula, and that's why they have same molecular weight. So can you tell me which factor we are going to use? Surface area. Which one will have more surface area? This one. That's why C, then A, then B. Got it? Darshan and Naiman. Very good. So this was about the physical properties. Darshan, are you done with this? Okay. Now the next topic is basically chemical reactions. And in this, we are going to see basically these chemical reactions are divided into three parts. The first one is nucleophilic substitution reaction. Nucleophilic substitution reaction. The second is elimination reaction. And the third one is reaction with matter. Reaction with matter. So basically, we are going to study about the chemical properties of haloalkanes and haloarenes, and we have three types of reaction. The first one is nucleophilic substitution reaction, then elimination reaction, and then reaction with metal. Write this and let me know. Then we will start with nucleophilic substitution reaction. Is everyone done with this? Please do respond. I'm waiting. Thank you. We're going to start. The first, that is nucleophilic substitution reaction. And basically, these nucleophilic substitution reactions are further divided into two parts. Okay, Darshan. Please do this and let me know. That's why I'm asking again and again that please do respond so that I will be able to understand whether you are done with the writing. Okay, thank you. Now you can see we are going to start basically this nucleophilic substitution reaction. So basically it's very easy to understand. There will be a nucleophile, and since we are studying, wait a minute, write a topic before that nucleophilic substitution reaction, and that is reaction of haloalkanes. We study here reactions of haloalkanes. We will also study about reactions of haloarenes, but first here we are going to start reactions of haloalkanes, and in this nucleophilic substitution reaction. Now you can see there will be nucleophile attack, and we are talking about haloalkanes. So I am going to take an example of haloalkane. This is X, and we can say this is haloalkane. Now what happens here? X is more electronegative than carbon. That's why there will be negative charge and there will be delta positive charge on carbon. And what happens here? X will take electron from carbon since it is more electronegative, and it will form anion and it will produce like byproduct. And now when X will take electron from carbon, carbon will be now electron deficient, and that's why this nucleophile will attack on carbon, and then this reaction, this product will be formed, and this reaction, this type of reaction is called nucleophilic substitution reaction. Is that clear? Is that clear? Now see, we are going to talk about nucleophile. Do you know what is nucleophile? So basically nucleophile is electron rich species, and we often call it nucleus lover. Nucleus lover. Basically in nucleus there will be positive proton and neutron. That means basically positive love. And whenever there is positive charge on a molecule or carbon, you can say, since we are studying about organic compound carbon, whenever there will be carbon positive charge on carbon, that carbon or carbocation will be electron deficient compound. And since nucleophile is electron rich compound, it can satisfy that carbon carbocation, because it is electron rich species. It will donate some electron to that carbocation, and carbocation now will be neutral. And in order neutrality is stability, basically you can say that. Now nucleophile can be of two types, three types you can say. Basically a compound with a lone pair, or a compound having negative charge, will be nucleophile. Like H2O, if you are going to talk about H2O, this will be nucleophile because it has two lone pair. Negative charge like OH minus, this will be nucleophile. Is that clear to everyone? Please do write it and let me know. Darshan, Ayman, and Madiha. Please do let me know when you are done with this. Are you done with this? Ayman, Darshan. Darshan, are you done with this? Thank you, everyone. Now, there is another type of nucleophile that is known as ambident nucleophile. Ambident nucleophile. To see what is ambident nucleophile. So, a nucleophile which has two nucleophilic center. So, we can write a nucleophile which has two nucleophilic center, that is called ambident nucleophile. For example, cyanide ion. Cyanide ion. You can see C triple bond N and there is negative charge, and we know that nitrogen has lone pair. Or we can write C double bond N and there is negative charge. Now, so there is two nucleophilic center, either it can donate from this or this side. So this type of nucleophile is known as ambident nucleophiles. Is that clear, everyone? So Darshan, there will be a backup extra class for solution at 8 p.m. for you. Ayman, if you want to join, or Madiha, if you want to join, you can. Is everyone done with this? Welcome. Darshan, are you done with this? Ayman? Okay. So as I told you that nucleophilic substitution reaction are of two types. So basically the first substitution, nucleophilic substitution reaction is substitution nucleophilic bimolecular reaction, also known as with this name SN2, which is very famous for SN2. So what is bimolecular and unimolecular? We will learn about this in chemical ethics, where we will study about molecularity, unimolecular, bimolecular, and termolecular. So in short, now I can say unimolecular, that means only one reacting species are called unimolecular. Two bimolecular is the one which has two molecularity, that means two reacting species are called bimolecular reaction. Now we are going to talk about this substitution nucleophilic bimolecular reaction, which is very important. Now see, basically this is OH minus and this is Cl and this is H. Now this is hydrogen and this is also hydrogen. So what happens here is basically this is hydrogen, this is hydrogen, and this is hydrogen. So basically this Cl and C, the bond between carbon and Cl, is about to break. At that time this OH minus will attack, and this is the basically this is the scenario of bond formation and bond breaking. Here there is the bond between carbon and Cl is going to break, and here it shows that the bond between carbon and OH is going to form. And what happens here is very easy to understand. Basically this is OH and this is hydrogen, this is hydrogen, and this is hydrogen. Why I just wrote opposite to the reactant, you will understand when we are when we will study about the stereochemical or stereochemistry of SN2 reaction. You can see that H of this dash is on the left hand side in reactant, but if you are going to see on the right hand side in product, you can see H is on the right hand side, and H, this H is like left, so it is also on right. Hydrogen on left, so it will be right. So basically there is a term inversion of configuration will take place in SN2. Why does this happen? I'll just explain. First of all, you are going to write it one by one, then I will explain what happens, why this happens. Please let me know when you are done with this. Is everyone done with this? Darshan, Ayman, Darshan and Ayman, I'm waiting for your reply. Please do respond. Very good, thank you. Now see, basically, first characteristic of this reaction is single step reaction. Single step reaction. This reaction carried it out in single step reaction. Yes, there's no problem at all. I'll explain it. Okay. Wait a minute, please. Sorry. Sir, can you install it? Yes, that's why I'm again and again asking, are you done with this one? Are you done with this? Thank you. Darshan, are you done with this? Okay, please do it and let me know when you are done with this. Mhm. Very good. So see, Darshan, what is this? It's very easy to understand. This line is basically represents, basically you know that sp3 it is, so it is tetrahedral. Tetrahedral, that means basically this molecule exists in 3 dimensions. So basically these lines, plane lines, is the represents, it is on the plane. You can see the screen. This is on the plane. When we talk about this is basically dash wedge. This is called dash wedge, and it is basically bond away from the observer. That means it is inside the plane. Bond away from observer, or you can see inside the plane. Inside the plane. And this is basically bonds towards observer. Bonds towards observer. So basically, this is outside the plane. Outside the plane. So whenever a solid wedge is written, this is solid wedge. This is called solid wedge. That means this bond is towards you, and dash wedge, that means this is toward basically opposite of you, yani. That means inside the plane. Is that clear? Please write this and let me know. Are you done with this? Please let me know when you are done with this. Thank you, Aman. Darshan, what about you? Darshan, I'm going to change the slide. Are you done with this? Okay, thank you. Now see, basically I have written 2 points for this reaction. The first is single step reaction. It will carry in single step. And the second is back attack. This reaction proceed by back attack, and why it is so? So you can understand there is CH3Br and there is OH minus. If it is going to attack from front side, what happens here? If Br minus, Br will take electron from carbon, so it will be Br minus. And if it wants to go to carbon, attack carbon, because now electron is carbon is electron deficient molecules, so there will be repulsion between these two nucleophile. This will become Br negative, and OH wants to go in the same way in which Br is present, Br minus. That's why a reaction does not take place, because proper orientation is not there. If this OH minus, if this OH minus will attack from back, you can see this will go negative, and now it will have positive charge. So OH minus can easily attack on this carbon, and this product will form. That's why in SN2 reaction, back attack is the only option. Front attack is not possible because of proper orientation. There will be two negative charge that will repel each other. So Br minus will not allow OH minus to go from the same way, because same charges repel each other. Is that clear, everyone? Darshan and Ayman. Thank you. Please do it and let me know. Are you done with this? Very good. Darshan, I'm going to change the slide. If you are still writing, please do respond. Okay, thank you, both of you. Now, see, I'm going to ask a simple question from you. It's from class 11. If I'm going to write, just focus on it. I'm going to write this in 3D. So basically, this is X, This is hydrogen. This is hydrogen. And this is also hydrogen. Now again I am going to take X. Now this is C, which one will have CH3 basically. And again this is H. And this is also. Now again going to now again going to write this. So please draw this, and there is a concept behind it. That's why I just did it. Please do this and let me know when you are done with this. Are you done with this? Let okay, no problem. Take your time. This is A, this is B, this is C, and this is D. So both of you done with this. So are we speaking? No. Are you done with this? Now see, Ayman, if X minus will go like this, in every case, X will take electron from carbon and it will go like this. Okay. Is my voice tracking? Please let me know. Ayman, is my voice tracking? No. Darshan, thank you. Thank you, Ayman. Darshan, what about you? It is, okay. Is your connection good? My network connection is good. If it is writing in your on your screen that the network is slow, that means your network is slow, I think, because I am looking at the. Hmm. Am I clear now, Darshan? Now see, and OH minus, since we know that now. Okay, turn off the video. Okay. Am I clear? Now see. Since we know that in SN2 back attack is only possible, no front attack. So can you tell me OH minus from where, in which of the following will attack on carbon? A, B, C, D. In which carbon OH minus will attack easily? In which of the following OH minus can attack easily? Any idea? Now see, it's very easy. I don't know, no problem. So it's very easy. You can see hydrogen, hydrogen, and hydrogen is very small group. So OH minus can easily attack. Now this is a CH3, which is a bulky group. So OH minus will go and there will be a steric hindrance. Now there will be two CH3 group. So there will be more steric hindrance. Now in this case, there will be three CH3 group. That means three bulky group. That's why OH minus will not easily attack here. So reactivity will be CH3x, then 1 degree, then 2 degree, and then 3 degree. Because in 3 degree, because in 3 degree, there will be more steric hindrance. Bulky group are more. That's why OH minus will not gonna easily attack. There will be repulsion also. Or the reactivity will be CH3x, then 1 degree, then 2 degree, then 3 degree. Got it? Amen. Thank you. Darshan. Darshan, is that clear? Should I move to the next part? Yes, speak up. Very good. Thank you. So I am going to change the slide. Now, for an alkyl group, rate of reaction for halogen. If alkyl group are same, that means all will have R group, then RBr, then RCl, and then Rn. So basically, iodine is the best living group. Iodine is the best living group. Iodine is the best living. So the reactivity, if the alkyl halide is common for all the halogen, then iodine, then bromine, then chlorine, then fluorine. Is that clear to both of you? Let me know when you are done with this. Then I'm going to give you some question. Then we'll move to the next part, SN. Done, both of you. Darshan, you are also done with this. Now there will be two questions I'm going to ask. Then we will move to the next SN1. So the question is basically, in the following pairs of halogen compounds, which would undergo SN2 reaction fast? So I already taught you about the degree of halogen. Please do this, and also predict the order of reactivity of the following compounds in SN1 and SN2 reactions. There will be question. This is not complete question. First do it and let me know. Are you done with this? Are you done with this and this? Okay. So take this A and this B. So which one will have would undergo SN2 reaction faster? The one which is more reactive. And can you tell me what is the degree of this halide and what is the degree of this halogen? What is the degree of halogens here? Two and three. This is 2 degree. Sorry, you can see this is 1 degree and this is 2 degree because this carbon has 2 degree and this carbon has 1 degree. And as we know that for SN2, 1 degree, 2 degree, 3 degree. So 1 degree will be more. Sorry, this is 2 degree basically. 1 degree is more reactive than 2 degree. So A is greater than. Is that clear? Very good. Now you can see both have same degree, 1 degree, 1 degree. Now iodine is the best living group. That's why it is. It would go SN2 faster than the chlorine. Can I? I'm going to change the slide. I'm going to complete this question. Predict the order of reactivity of the following compounds in SN1 and SN2. First, predict the order of reactivity of the following in SN2 in SN2 because we had completed only SN2. So the first question of this, the four isomeric bromobutanes. Bromobutanes. So you are going to write the isomers of bromobutanes and then arrange this in then predict the order of reactivity towards SN2. Can you do this? Please let me know when you are done with this. Did you write the Ammon? What is the isomeric bromobutane? So bromobutane is basically CH3, CH2, CH2, CH2Br. This is the first isomers. Now the second isomers I am going to write is basically CH3, CH2, CH, Br, CH2. So wait a minute, let me do this in another. Now the next we can write CH3, CH, CH3, CH2, Br. Now CH3, CH2, CH, Br, CH3. And the last one is basically Br, CH3, CH3, and then CH. Again, if you are going to check it, A, B, C, D. Let me know. This one will have highest, most rate of freeze, highest rate of freeze. Can you tell me, Aman? Not B. C. First concentrate. This is 1 degree. This is 1 degree. This is 2 degree. This is 3 degree. So as we know that 1 degree, 2 degree, 3 degree. This is the reactivity series. Now both are 1 degree. Which one is more crowded? This one, because CS3 is here, but there is no CS3 here. So A will be the highest, then B, then C, then D. Is that clear, Aman? Please let me know when you are done with this. Understand. Oh, A and B, C. CH3, CH2, 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 B. This is 1 degree. And if you are going to see about D, CH3, CH, CH3, CH2, D. This is also 1 degree. Now, if this will go, there will be attack of OH minus. And if this will go, there will be attack of OH minus. But the problem is that this CH3 and CH3, two bulky group, and you can see this is only one bulky group. Okay, or you can also see in this way. Wait a minute. In this way, you can see this carbon has hydrogen and hydrogen. Also, this carbon will be hydrogen and hydrogen. Now, when we talk about this, when you talk about this, see, there will be CH3, or you can, if you want to understand it. So there will be CH3 and hydrogen, and then there will be carbon, hydrogen, hydrogen, and then CH3. So there is a bulky group present here that will repel this OH minus. That's why it is less reactive towards this SN2 You can say this is hydrogen, this is hydrogen, this is also hydrogen, this is also hydrogen, this is CH3, so there is CH3. So basically, due to the presence of this bulky group, it is less reactive. Since both are 1 degree, so we will go for bulky group in which there is more bulky group. That means there is less reactivity. Is that clear? Are you done with this? Should I give you another question? Are you done with this? No, you're done with this, Simon. Now I'm going to give you another question. Which compound in each of the following pairs will react faster in SN2 reacts with OH minus? The first one is CH3Br or CH3I, and in the second one you have to choose between CH3 whole thrice CCA or CH3. You can take this A, B, A. Very good. So that means SN2 concept is clear. In next class we will go for SN. Okay. So this is it for today. If you have any doubt, you can ask me now, or you can bring your doubt in the next class, or you can ask in the group as well.